Okay, hi guys. A little project that I've been working on. I know other guys on YouTube have done some similar projects, but this is my spin on it anyway. So effectively, this laptop is a standard, or a fairly standard Chromebook. I lie, it's no longer a standard Chromebook, but it did start off life as a standard Chromebook, Lenovo Chromebook N21, so fairly low spec, quite old now in fact. Relatively cheap purchase from eBay, and that's kind of the attraction. So where do we start? Obviously a Chromebook running Google Chrome, it's great for certain things, not so great for ham radio applications. So what I've done with this one is I've effectively removed the protection on it, and then installed Linux Mint in this case. Could be pretty much any flavour of Linux you like, doesn't matter too much. And then on top of Linux, I've installed a number of different ham radio applications. The first one I'll tell you a bit about is this one. This is Conky. If you're familiar with sysinfo, it's kind of similar to that in some respects. And this is interfacing with various other applications that I've got installed. First of which there you can see the grid square, so there's some services behind the scenes interfacing with the GPSD service, which is getting the coordinates from a GPS and effectively converting that to a maidenhead grid locator. Local time, Zulu time, system resources, IP addresses, and various radio tools and services. Red, as you can see it now, indicates that they're not currently running. If it goes green, indicates that they are. And the config configuration can be modified to suit your own purposes, but this is set up the way I want it. Okay, what else have we got? So, usual suspects here: FLDigi, JS8 Cool, WSJTX, Zastir, APRS, Winlink, which is actually using a combination of PAT and Ardop. Reset ham radio services will come on to, Gpredict, a couple of flavours of that, and some AX.25 Packet connections. So let's start with the simple stuff. So it's worth noting, or worth pointing out actually, that currently this is connected to an Icom 705, but I've tested the same configuration, or varying flavours of this configuration, with a Zygo X5105 and a Yaesu FT817, and it'll work with whatever you want. Ideally, you want a USB interface that carries audio and cat control signals. If you haven't, you could carry the audio separately, but this is obviously a much more convenient way of doing things. But either way, it can be configured to work. So we'll start with FLDigi, and if we just launch it from the shortcut down here. So there you go, up comes FLDigi, and let's just check the cat controller's working. So you can see the radio is currently on 14070. If I flick up the cat control, frequency 14071, there we go, 14071 on the radio, we can see that's working. If we click tune on FLDigi, take a look at the radio, you can hear the audio going out there. You can see that the PTT is being engaged, so it's transmitting. Okay, only into a dummy load on very low power, not going anywhere. Okay, so worth pointing out here that a lot of applications still don't fully support the IC-705, but they will almost all support the IC-7300, and because for the most part the cat commands are pretty much the same. The only real difference is that other than the extra bands 2 meters and 70 centimeters that the IC-705 supports, that the 7300 doesn't, the key difference is the CIV address. So if we just go on the radio, have a look, go into connectors and CIV. Now the default address on a 705 is actually A4 hex if you like. But I've set this up for 94 hex, which is the default CIV address for an Icom 7300. Okay, for a lot of you, I'm probably teaching you how to suck eggs, but this may be useful to someone that hasn't already been through this. So it's worth noting here, if you're familiar with FLDigi, you'll probably already know there's a number of different ways to configure it for cat control. It's actually really flexible, but because I wanted to use this for CW as well, and in later versions of FLDigi, certainly from 4.1.18 onwards, can't vouch for any previous version, but certainly 4.1.18 will work with CW keying, and we'll come on to that in a second. But in order for that to work, you have to be using either FLRig or RigCat. So I've opted to use RigCat, just my personal preference, but either way theoretically should work. I'm saying theoretically because I haven't actually tested it with FLRig, combining it with a CW modem, but the theory is it should. So here you'll see that for RigCat, I've got a rig description file, IC-705 space 94H.xml. Now that's actually one that I've modified, because the default IC-705.xml file, which is downloadable, has the default CIV address set for A4H, which is the default for the radio. So it's absolutely correct. But the problem with that is then everything needs to be set up to communicate with the radio as A4H. And clearly, as I've already shown you, I've set this up for 94H. So what I've done is I've basically created a copy of that file and then modified all the address references to be 94H instead. Not exactly rocket science, but it's all that you need to do to overcome that problem. So it'll talk to it using the 705 configuration file, but using the address of a 7300 in simple terms. Other than that, it's all fairly standard stuff. I've already shown you that it works. But the benefit of doing this is then if I go up to modem CW, okay, and then go and look at cat keying, it means that I can set it up as an icon with the 94H address that we've specified, disable cat PTT, so when it's basically sending CW, it will key the radio slightly differently. It won't use the standard cat. It'll effectively key it, CW keyer built into the radio. So I'm not explaining this very well, but that's the point of the exercise. Otherwise, I could have theoretically got away with just using the standard 7300.xml file and it would have worked fine. But since we're on the subject, so 14070 currently BPSK 31, okay, and you can see my filtering options there, whatever. And let's just send out a CQ. Clearly, we've already said we're on the dummy load. No one's going to hear us. We're running next to no power at all as well. Okay, here we go. There we go. We're sending a CQ using PSK or BPSK 31, and we can see that's going out quite happily. So we'll let that complete. And then if I wanted to go, right, let's go play some CW, so I would go further down on a 14010, something along those lines, switch the radio into CW because I want to send CW using the keyer built into the radio. I don't want to send audio to the radio and send CW using USB, although, you know, that's an option if that's the way you want to go. And then I'm going to, it's actually already set that up. All I need to do is change my op mode to CW. There we go. Now we can see it's set my filter width. I mean, all of this is configurable. Do it whichever way you want. Filter width to 500. I'm in CW. There you go. CW there. Happy days. Okay. And I'll come down to monitor at about 600 Hertz. Okay. And then if I send a CQ, we can hear it going out via the radio in native CW mode, and it's keying the built-in keyer on the radio. Great stuff, because previously you would have needed something like one of these little boxes down here. Great little piece of kit, but it's an extra piece of kit to carry with you. If you're running portable, you don't really want that Winky USB. So I definitely recommend that, but as it turns out now, you don't really need it so much. Although it does have some benefits, but I'm not going to go into that on this video. That's pretty much enough, I think. So let's just switch this back. I'll show you how straightforward this is. Okay, there you go, USB-D. Okay, we'll change the op mode back to, in this case, PSK 31. Okay, and we're done. That's it, simple as that. So that's I think, pretty straightforward. You can switch between CW and PSK or any other digital mode in literally seconds. Happy days. Okay, and we'll come out of there. Let's see what I'm doing. So I'm doing this with a phone, so it's not the best video, I'm afraid, but I thought it might be useful. Okay, and just to demonstrate then, so if we go into JS8 Cool now, it takes just a couple of seconds to start it up. I mean, this is not the fastest laptop in the world. It's only a 1.6 gig processor, but for most ham radio apps, it's absolutely fine. And as I said, it's cheap. So if you break it out in the field, no one's going to cry over it too much. Break your brand new MacBook or whatever, that might be a different matter. So, okay, here we go. JS8 Cool. Okay, and just to demonstrate the cat control is working. We go to, that's 20 meters, there you go, 14078, set that on the radio, no problem, click tune. Okay, we can see that the audio interface is working too. Now I'm just going to point this out, so if we go into the settings, okay, and we look here under radio, you can see it's currently set up for IC-70300, and this is the same theme throughout with any of the other apps. Everything's pretending, well, sorry, the radio is pretending to be an Icom 7300, and the only exception is where we're using the 705 config but modified for FLDigi. Again, all pretty simple stuff. Okay, and WSJTX, just to prove the point. So if we fire up WSJTX, and you can see that, there you go, it's gone green, so it's started the services up. Okay, and up it comes. Okay, and we'll set the frequency there. We'll stick with 20 meters. 14095.6. Okay, set that on the radio as well, so the cat's working. Click tune, it's working. And this is exactly the same principle as WSJTX, sorry, as JS8 Cool, I should say. So go into settings, into radio, and we can see it's set up for an IC-7300. Okay, no need to do anything more with that. That works. Okay, so now for anyone that's more interested in VHF digital comms, so here we go. We've got Zaster APRS. We launched that. And that's basically running a script behind the scenes, and this is using Hamlib to set the radio up. So it's running some Hamlib commands, so rigctl commands. We can see there it's put it into FM digital mode 144-800, and you probably heard there that it sent out some AX.25 packet traffic. Now I've got all the pretty maps disabled just to keep things a little quicker, but you can see there, well, you can see it's plotted my location. It'll have got that from the GPS. And if I go into message, general stations query, you'll hear the traffic going out on the radio there. Okay, and obviously if we weren't running on a dummy load, then we'd expect to see quite a few replies coming back. Just show you this very quickly. If we go into the interface control, you'll see we've got three interfaces here. One is for internet server, so that would, if enabled, if I could start that, whatever, that would basically connect to APRS servers out on the internet. Network GPS is connecting to the GPSD service, which is running on the laptop, so it's a Linux service, and that's taking its feed, in this case, from the built-in GPS on the radio, but it could be any GPS source you wanted to. And then we've also got AGWPE, which is basically Direwolf, which is a soft modem, and that's how we're communicating out through the radio. So any of all the traffic is effectively sent to the soft modem, and then that's converting it to audio and sending it out through the radio. Pretty simple stuff. Okay. And then obviously if we wanted to use messaging, you know, once we're connected, either using RF or over the internet, whatever, then that'll work. Or a combination of the two, if you like. If you're familiar with Zaster, it's pretty easy to set up digipeating between multiple different connections. So as we come out, you'll see KISS attached, Direwolf and Zaster, they'll all close off. It was all part of the script. Then let's look at something else. So satellite tracking then. Now obviously the IC-705 is not full duplex, so it will operate half duplex quite happily and enable you to tune the uplink and the downlink for Doppler. So as long as you're not too fussed about hearing yourself on the downlink, it should work. It does work, as long as you've got a decent antenna system. So Gpredict has a few limitations. It's a really good piece of software, but it won't allow you to send mode control or mode cat commands to the radio via via Hamlib, rather I should say, using the RigCTL commands. But you can set the radio up first and set it back afterwards through some simple commands in a bash script, the same as everything else is being done effectively. So I will show you that. I'm not going to show you the scripts because we'll be here forever if we do that, but if I just launch the script behind that icon, you can see here it's put the radio into split mode. It hasn't bothered setting the frequency, but it has set the modes. You can see we're USB there. If I toggle around to VFO-B, it's LSB there. So it's set the modes up, and this is why, incidentally, there are two icons on the desktop, one for FM and one for SSB, because I need to tell it how to set the radio up, and they're kind of the two options. Obviously, if you were running PSK or AX.25 or something else, then you need to write some other scripts that were more relevant to that application on whatever satellites it happens to be. But you know, this is really just a toolkit. Kind of set it up whichever way you need to. So if we go into antenna control, XW2A is up at the moment. Not that we'll hear anything because we're on the dummy load. But if we select XW2A, tell it to track, click T for the center of the transponder, click engage, you can see there it's tuning my downlink on 2 meters, and it's still got the mode set to USB. Let's just turn the monitor off, otherwise it's going to squeal at me. If I click the PTT, you can see it's uplinking 435.044.91 whatever 95 counting. So that will correspond to the uplink and the downlink compensated for Doppler. So again, as long as you don't want to hear yourself on the downlink, that should be absolutely fine. So we can come out of there. That'll take the radio back out of split mode. In fact, the last instruction it sends it is to set it back to USB-D on 14070, ready for some more PSK work. But there's actually a really good reason for setting it back. There's a little bit of a quirk when you start FLDigi. If you leave it on a VHF or UHF frequency, anything that's not HF, and then you go to start it up, sometimes it seems to get a little upset and it won't initialize the cat control properly. So just to avoid that happening, the final part of any of the scripts that I run effectively sets the radio back here. You can set it any way you want. That's entirely your choice, obviously. Okay, so having done that, just to prove the point that it does now work, if I launch FLDigi again, okay, that's come up 14070. If we up the frequency, there you go, that's working. So little gotcha there. Okay, and let's just put the monitor back on. There you go, so we can see the USB audio is still working fine. So we'll come out of there. Let's just close FLDigi. Service is stopped. And the last piece of the pie, no, not quite the last piece of the pie. So we haven't looked at Winlink yet. Let's show you that. So this is a combination of PAT and Ardop, which when it refreshes, there you go, PAT, RigCTL and Ardop, RigCTL being Hamlib obviously. Okay, so there you go. It starts up a number of services behind the scenes and sets the radio on that particular frequency. That's just an arbitrary frequency. It could be anything you want. It doesn't really matter, because when we come in to connect here, okay, we're going to say, yeah, we're going to use Ardop, all right, but I'm going to say, right, let's show me the RMS list, and I could filter it further, but we'll just pick any one for now, okay, and click connect. Obviously this won't actually work, again, only on dummy, but you can see here, it's set the frequency on the radio, and it's keying up and sending audio via the USB. Just happened to already be on the correct dial frequency. I'll pick another one in a second just to show you that that does work. So that'll time out eventually, obviously. Under normal circumstances, you'd pick a station that you had a fighting chance of hitting. Okay, there you go, unable to connect, as we'd expect. So if we do it again, click connect, this time I'll select one on the 20 meter band, okay, and we'll go for any one, doesn't really matter. So you can see here the frequency 14108.9, and you can see it's set that on the dial frequency on the radio. So click connect again, okay, you can see here it's trying to connect, you can hear it going out on the radio. And eventually that will time out again. Okay, there you go. So that's timed out as we'd expect. So we can close that, and then the last thing it will do is go and stop all of the services again and set the radio back 14070. All right, almost there. Last piece of the pie. So AX.25 Packet bulletin boards. This could also be AMPNet access. It's easy to amend the script to include a KISS attach with an IP address, but I've not done. It's in the script, but it's basically rendered out at the moment, or commented out, I should say. So if we just start this one up, this is a script to connect to GB7SOU, which is one of the local packet nodes to me. Okay, so the first thing it does is go and stop all the ham related services just so it doesn't trip itself up. It'll then try and connect. Because there's a small bug with this particular version of the AX.25 stack, sometimes there's a bit of a delay before it attempts that, but eventually you will see it send its first packet, and you should hear that go out. You'll notice also that it set the dial frequency to 145.950, set the mode to FM digital. There you go, there's our first packet. Now obviously it's not going to connect, so we'll kill that off with a Control-C. Obviously that means that it won't complete the script, so it's left KISS attached and Direwolf services still running, but not a problem, because we can just click our reset ham radio services and that stopped everything. And we can see then it set the radio back, and that's it. So hopefully that was useful. Maybe it gives you a few ideas, in terms of the art of the possible. I was going to say on a bit of a budget, but obviously the radio is not the cheapest radio in the world, but it'll work just as well with an old 817 or a Zygo or anything else you care to mention, as long as you've got the cat control and preferably the USB audio. But the laptop itself, cheapest chips from eBay, a couple of hours of your time just to remove the protection and install a copy of Linux. Plenty of good information out there on the web. So for anyone that's managed to get through their ham radio license, it really shouldn't be too hard. Anyway, chaps, hopefully that was helpful, and I'll speak to you soon. Cheers, bye.